At dawn, the salt flat looks empty. A white horizon, blue sky, no sign of what lies beneath. Far below the crust, ancient brine is drawn upward, carrying a question every battery leaves unanswered. How can a device sold as clean begin in one of Earth's driest landscapes? The answer is not one stolen mine, one corporation, or a secret map. It is a chain of decisions that begins inside a vanished lake and ends inside the objects held in our hands. To follow that chain, we enter the high Andes, where salt flats are not blank maps, but basins shaped by water, wind, memory, and law. Across parts of Argentina, Bolivia, and Chile, closed basins collect minerals washed from surrounding rock. Over vast spans of time, water evaporates, salts remain, and lithium concentrates in underground brines. The phrase Lithium Triangle is useful only if it does not erase the differences inside it. Separate countries, communities, watersheds, and political histories. Long before lithium became strategic, indigenous peoples lived, traveled, traded, and maintained relationships with these high-altitude landscapes. A salt flat can be territory, livelihood, wetland system, and sacred place at once. That is what a resource map tends to flatten. It marks deposits, not every obligation attached to the land above them. Lithium was once valued mainly for specialized industrial and medical uses. Rechargeable lithium-ion batteries made it strategic for electronics, electric vehicles, and grid storage. Demand has climbed with the spread of batteries. While governments and companies compete to secure materials they fear they may one day lack. Yet the language of a rush conceals a more ordinary reality. A battery passes through miners, chemical processors, refiners, cell makers, manufacturers, traders, lenders, regulators, and consumers. The real mystery begins at the wellhead. In conventional brine operations, mineral-rich brine is pumped from beneath the cellar into evaporation ponds. Sun and wind remove water, salts crystallize, and the remaining liquid grows more concentrated. Chemical processing turns that concentrate into lithium compounds for industry. The geometric ponds seen from above are not the battery itself, but an early chapter in a longer process. No two salt flats are identical. Their brines, aquifers, climates, and links to freshwater can differ. An aerial image may look simple while hiding a difficult hydrogeological system. Here, the public argument often becomes confused. People speak of water as though every liter beneath a salt flat behaves the same way. Brine is highly saline. Freshwater supports people, wetlands, grazing, and ecosystems. In some basins, their relationship is limited. In others, it may be connected, uncertain, or contested. That uncertainty is not a technical footnote. In a desert, it is the central drama. Scientists can measure pumping, rainfall, springs, water tables, and lagoon chemistry. But understanding a basin needs long records, careful models, and honest recognition of what remains unknown. Without a reliable baseline, a later decline becomes an argument with no agreed beginning. Was it drought, climate variability, another industry, mining, or several forces together? Nearby wetlands and lagoons can support specialized plants, migratory birds, and pastoral economies. Their vulnerability does not prove every operation caused every change, but it demands rigorous, transparent monitoring. The story shifts when permits enter the frame. A permit may authorize extraction under national law. It does not settle whether consultation was meaningful, whether data are public, whether benefits are shared, or whether communities can challenge a decision safely. Across the Andes, indigenous and local communities have raised concerns about water, territory, cultural continuity, and participation. Companies and governments point to investment, employment, infrastructure, and lower carbon technologies. Both sides describe real stakes. The failure comes when one is treated as modern and the other as an obstacle. A mine can create revenue, roads, contracts, and technical jobs. It can also leave communities carrying uncertainty over changed water systems after the concentrate has crossed a border. Then the chain moves on. Lithium chemicals may travel thousands of kilometers before becoming cathode material, cells, vehicles, storage systems, or electronics. The country of extraction does not necessarily capture the greatest share of value created later. That imbalance gives the word colonization its force. It should not be a shortcut for every foreign investment, or a claim that one hidden power controls a continent. It is better understood as a warning about an older pattern. Landscapes export raw materials, while higher value processing, patents, finance, and profits gather elsewhere. The pattern did not begin with lithium. South American economies have long faced pressure to export unprocessed wealth while importing costly finished goods. Today, lithium revives that question under the language of clean energy. Who decides whether a salt flat becomes a sacrifice zone, a public asset, a locally governed resource, or the basis of a new industrial strategy? The answer differs by country and project. Bolivia has pursued state-led ambitions around its salt flat resources. Argentina's provincial structure has encouraged a different landscape of projects and investors. Chile combines major production with its own environmental and indigenous rights debates. Treating the region as one seamless battery colony hides those differences. It also makes reform sound impossible when it is a matter of contracts, standards, institutions, and public choices. Another promise now circles the industry: direct lithium extraction. Unlike evaporation ponds, newer approaches aim to separate lithium from brine through filters, sorbents, membranes, or other processes. Supporters say this may shorten processing and reduce pond area. But direct does not mean impact-free. These systems can require energy, chemicals, water management, replacement materials, and plans for brine after processing. Their performance depends on the technology, basin, power source, and independent data. The test is not whether a process has a futuristic name. It is whether communities and regulators can see what enters, what leaves, what returns underground, and what happens when predictions fail. Transparency is not an accessory to the energy transition. It is part of the technology. Public water data, independent ecological monitoring, meaningful consultation, enforceable limits, and traceable supply chains are less cinematic than blue ponds. But they determine whether a battery carries accountability as well as charge. Battery chemistry is changing. Some designs use less lithium per unit of energy, while others use different material combinations. Recycling may reduce pressure on primary extraction as more batteries reach the end of their lives. None of this erases immediate demand for mined materials. It does expose the weakness of the claim that there is only one possible future. The clean energy transition is often presented as a race against time. Climate risks are urgent, but urgency is not permission to repeat extractive mistakes under a greener flag. A phone, an electric car, and a grid battery can reduce dependence on fossil fuels. They can also hide the places where their material history begins. Every smooth screen contains a geography of wells, contracts, laboratories, shipping routes, and political choices. The object feels weightless because its weight has been moved elsewhere. The deepest theft may not be lithium itself. It may be the disappearance of context. When a salt flat becomes only a deposit, water becomes only an input. When a community becomes only a stakeholder, consent becomes a box to tick. When a battery becomes a symbol of progress, responsibility is easy to export. The archive beneath the salt tells a different story. It records ancient water moving through volcanic rock, long human presence in an extreme landscape, and a mineral now pulled into a global transition. It also records a choice that technology alone cannot make. The question is not whether the world needs batteries. It is whether their source regions will be treated as expendable or as equal authors of the future. Those batteries are meant to power. Because beneath every white horizon lies more than lithium. There is water, memory, sovereignty, and the unfinished right to decide what must never be taken for granted.